Hi there, and welcome to a lecture on writing classes where we turn our ideas into objects. Warning, please read chapter 10 before watching this lecture. Just open up the textbook, read chapter 10. If you already know about classes, skim chapter 10, then come on back here and watch this video. Our objectives during this lecture are to learn how to write a class that represents a real-world thing, multiple classes, hopefully, because generally you can't get away with just one unless it's like a simple little homework problem. Then we'll learn how to create an object from that class. And then finally, we'll learn how to use that object to actually do things to make our program work. This is the same problem that we looked at before, the same problem domain. A problem domain, given this thing here, we want to write software to be able to do it. So a quiz is made up of 10 true-false questions and 5 multiple-choice questions, and each multiple-choice question has some options, and after someone takes the quiz, we should be able to see how many answers they got right. That's it. So that's our problem. And we did some domain analysis to break it down into the different nouns that we've got here, the quiz and the true-false question and the multiple-choice question, and then also the verbs, getting the score and adding a question to the quiz. There's also maybe administer. And then for the question, is correct and set response for both of them. So let's talk about how we actually write a class in Python to encapsulate these ideas of data and functionality all packaged together into one little object. The parts of a class that we're going to look at in this lecture are the name of the class, which is how we'll refer to it to create objects. It's the car class, which means that we're going to get objects of type car, that they'll be car objects, or they're a person class, and when you create an object from that, it is a person object. The initializer is what we use to make sure that the object has all the data that it needs at the time of creation to do something right with. And there's lots of ideas about this in the object-oriented community, and I just won't go into it right now. But there's some what I would consider to be a lot of bad practices out there in the object-oriented community. But our initializer, like I said, should be the function. Should say I need all of this data for my object to be good when it is created. So, for example, if I have a person object, I could say that I absolutely need their name to be able to create a person object. So I can't create a person object without a name. And so that's what we use the initializer for, to say, here is the data I need, please provide it to me. And then finally, the methods that we use to interact with that object, like when we use .append on a list to add another item to the list inside that list object. When we use .append, we are interacting with that data inside of that object, and it's adding one to us. So we're going to write our own methods to interact with the data inside the object. The first part of any class declaration is the keyword class followed by the name of that class. So in this case, we're going to create a class, and it's going to represent our true-false question inside the quiz. You'll notice here that I say that it's Pascal cased. And what does that mean? That means if it has more than one word, each word is capitalized and the first letter is capitalized as well. So this is called Pascal cased, as opposed to example snake case, which we've been using. That would be something like true, false, question. This is not how we name our classes in Python normally. And if you go look at the Python style guide, you'll see that it says, try to use this Pascal cased version of it. So we're going to stick with this Pascal cased version where each letter, including the first one of each word, is capitalized. So this is our class, the true-false question. The next thing that we'll put inside our class declaration is the initializer. So it has a special name. It's __init___. That means initializer. And so this will be the function that runs when we create a new object of true-false question. So what does it mean for us to create a true-false question? In this case, it means we need the text of the question And then we need to know what the correct answer is. Is it true or is it false? And so we'll put that answer inside there, true or false. And so, we'll say something like our text, something like, is the sky neon green? And the answer would be false. And so that represents a true false question. Inside this method, and notice I'm calling it method now. I'm not calling it a function because methods are functions that belong to a class. And so our class ends with a colon, which means everything indented underneath it is owned by that class. This is a function which is owned by that class. And so therefore it is a method. It is a method on that class. And we call it the initializer method. And then this def ends with a colon, just like all of our other defs. And everything inside there is part of that function. So what's interesting, what we see here is something new. We've got this thing called self. And what is self? In Python, whenever you have a method for a class, an instance method is what it's called, the first parameter is always going to be self. And that's the way that we set data attributes on it. So we're getting text passed into our function. We're getting answer passed into our function. And then self is provided by Python. So Python provides self for us. Then we use those variables, those function variables, right? So these are variables, these are parameters. So they're parameters for this function. And we set self dot something equal to that variable. And so what it's done is it's stored that value inside what we call a data attribute on this object. And so dot underscore underscore answer is a variable for this object, variable for the object. And so it travels around. That's the data that is inside the object. So when you have a list, for example, there's a self dot like first element, and that would be the first element, and self dot second element, that would be the second element, that kind of thing. So in this case, we have a variable, a piece of data, an attribute of the true false question, which is called underscore underscore answer, which is going to contain the answer that we provided when we create it. And we're going to see an example, multiple examples of this in just a little bit. So if this doesn't make sense just yet, don't worry, we'll take a look. We also needed a way to be able to set the response. So again, we create another function, which is now a method because it's indented inside the class, right? It's part of this class here. It's indented underneath here. So because it's indented, that's part of the class, right? So everything, when we read our Python, we look at the indentation to determine. So we have a class, true, false question. Now it has two methods, the initializer method, which gets called when we create the class, and then also the set response. And again, the first parameter is self. Python will do that for you. And then response is the value that we're passing into that method. When we do the dot append some value, that's the value that would be that second parameter. And so again, we create a new data attribute here on the object, on self, called underscore underscore response, and we set it to the value that's being passed in. Okay, so we're saving that data inside of our object. So inside of our object, if we think of our object as, a box of data that's hanging out, after we call init, it's going to have an underscore text variable inside it, an underscore answer variable inside of it. And now after we call set response, it'll have underscore response variable inside of it. And each of those will have data. If you read the text, you'll know that underscore makes it like inaccessible outside. And we'll see how that works when we actually program and step through it with the debugger. And then finally, the last verb that we had was whether or not something is correct, whether or not our answer was correct. When we provided a response to this question, is it correct? And so what is correct? The correct would be if our response, if our self.response here is the same as self underscore underscore answer. And I'm not going to say underscore underscore all the time. So in this case here, is correct is just a Boolean value. And what we do is we return the comparison of self.response and self.answer. So if those two things are the same, then it's correct. And if they're different, then it's not correct. So think about that. If we had something like, is the sky neon? Is the sky neon green? And obviously that answer would be false. And somebody types in true, and that's the value that we set to the person's response, then that would be self.response right here, which is true, compared to self.answer, which we got in here, which was false. And those two things aren't the same. And because they're not the same, this will return false. So that answer wouldn't be correct. That response would not be correct when somebody typed it in. I'm just going to underscore again here that we are taking the data that we want, these two, these two things here, our text and our answer and our response. And rather than having them as variables outside of our function, outside in a global space, they are all scoped by this self dot. And that's really important, right? Again, self dot, self dot, self dot. That's storing those values inside the object, on the object itself, so that later in other functions, like right here, is correct, we can respond to self dot underscore underscore response. That's the value that was called, or that was set when we called this method. And self dot underscore underscore answer was called, or was created when we called the initialize method. We called that right here, okay? So we wrote that code. And so the self dot thing, that's the thing that allows us to put data inside our object so that we can then again use it later. And then finally, if we want to be able to print out this question, what do? Well, to get a string representation of a class like this, we override the underscore underscore str underscore underscore, which means that, hey, when I call print, when I say print this object, when I print this thing, it's going to call this string method, this underscore underscore str underscore underscore, or dunderstring, double underscore. And then it will return a string, which starts off with true or false, and then adds the text to it. Is the sky neon green? So over here on the left, we have this entire class declaration. So we have the class keyword, the name, our initializer, some methods to interact with the data, and then a method to, when we print an object of it, we end up getting the string representation. So over here on the right-hand side, this is how we actually use this class. So here we use the function or the class name true false question, and we pass it these parameters. And these parameters end up getting sent to the initializer. Okay, so they end up going to the initializer. Let me just erase everything so that I can make it pretty. So this parameter here becomes text, and then this parameter here becomes answer. Okay, it's really important to note, Python always provides the self. You don't say self over here when you call this thing, okay? Self comes from Python. So this comes from Python, like that. So we provided this parameter and this parameter, and then they get bound here, that argument and that argument, and then they get bound here to these two parameters. So the sky is neon green becomes text, and false becomes answer, like that. And then we store it inside here. When we call print q, and so once we have this thing, once this is created, it creates an object and puts it into our variable for us. So now we have a true false question object inside that variable that has text on it and an answer on it. That's the data that's stored inside there right now. So when we print q, it calls this function here and prints this out. Then when we call q, which again is an object of this class, .setResponse, it calls this function here. And we pass in true, and so true ends up coming inside here. And that's what the value that gets up here. Remember, self is always Python. And then we print q is correct. And when we call is correct, dot is correct, it goes to that function, that method on that class, and then prints out, calls that, returns a Boolean value, and then prints it for us. Okay? So again, all this class stuff and data stuff, all of this data and method stuff, it's all about affecting again, top to bottom, right? So it affects the top to bottom. Here, We have this class here. So when we call, I'm gonna change it over to highlight here. Whenever we call this initializer here, it ends up calling this function here. Okay, so we end up going to that function. And then next, when we print out Q here, it goes and gets the string. So it calls this function here. So it goes back to the function. But the difference is because it's an object, because we're using a class, we have this self keyword, and there are those data attributes, that data that's shoved inside the object, okay? And then what we end up with here is we set the response. So when we do that, we're ending up calling this function here. So it's not top to bottom anymore, right? When we get to this line of code, it comes back to this line. And when we get to this line of code, it pops down here. And when we get to this line of code, it pops up here. And then for last but not least, when we call is correct, that calls this function here. And so again, top to bottom, it goes from here over to here and gets that value. So a class is about code organization, putting our functions inside a class so that we can shove data inside the object that the class creates. And when we shove data inside there, that's then available to other methods, to other functions inside that. So I want to show you that because that's really important to understand. In the init function here, we are creating the data attribute dunder text right there. You see that? But because it's shoved into that object, because it's shoved into the self, down here, when we print this out and a dunder string gets called, this self has a .text on it. So that's how we're able to set a value here. We're going to set a value here, and then we're going to get a value in another method, okay? The methods are all tied together because they all have self. They all respond to the self, the object, the individual object that is created here when we call the initializer. Some vocabulary for you to learn. The word abstraction is just any class. Technically, it's anything that you do to put data together to represent something. But for us, our first class abstraction in an object-oriented program is a class, okay? So an abstraction is any class is an abstraction. And then encapsulation is the idea that we're putting the data, all of the data, see all of this data here, we're putting it inside the object, and then we're creating methods for it. We're creating functions on that object that can then set and modify those values, okay? So that's what encapsulation is. Encapsulation is both the data and the methods that go together on a class to define an object. Again, classes are abstractions of real-world things because real-world things have an infinite number of properties, of attributes to them. I'm Curtis, and so what is some of my attributes? My name is Curtis. I've got long hair. My eyes are brown. I've got 3 quadrillion cells in my body. All of those are attributes of this meat bag thing that is me. But in my programs, I will never, ever create a person class that tracks the number of cells in my body because it's just not important. So we're abstracting away the dumb stuff and only keeping the stuff that's important for our program. Then classes define the data and how its objects will behave. And those are the methods, okay? So the data are the data attributes that we put on self, and the behavior is the functions, the methods that we define on that class. And then finally, instantiating an object means creating an object using the initializer of that class. So now that we've gone over all of this terminology and seen some code, let's actually sit down and go through watching me write a command line quiz program.